In occupied France, August 1943. On a distant German airbase just after 4 in the morning, Lieutenant Werner Schultz got news. He was the chief technical officer for Jagdgeschwader 26. This news should have been a triumph. An American P-47 Thunderbolt plane had been forced down. Its pilot was captured. The aircraft itself was mostly intact. This was vital intelligence. For months, German pilots had met this huge American fighter. They reported capabilities that seemed impossible. German engineers would now study one closely. When Schultz first saw the P-47 on the runway, his first thought was like every pilot's. It looked strange. It was a very fat and clumsy flying milk bottle. As he began his careful look, he found a terrible truth. Schultz, an engineer of facts, saw the P-47 as a prophecy. Its parts showed with numbers that Germany had already lost a war. Its leaders did not even know they were fighting. Schultz was not a combat pilot. He was a plane engineer. He had worked for Messerschmitt before the war. His job was to understand enemy aircraft. He identified weaknesses. He also suggested ways to fight them. When he arrived at the airfield, he saw the P-47 for the first time. His first thought, like every German pilot's, was that this plane looked strange. It was very fat and clumsy. The plane's body was huge. It was built around a very large radial engine. The aircraft weighed almost 8 tons fully loaded. For comparison, Germany's main fighter, the Focke-Wulf FW-190, weighed about 4 tons. German pilots had nicknamed it the flying milk bottle. Seeing it on the ground, Schultz understood why. It looked like it had no business being airborne. But Schultz was a scientist. He cared about what it could do, not its looks. As he began his inspection, what he discovered would shake him deeply. Schultz began with the heart of the machine. This was the Pratt & Whitney R2800 Double Wasp engine. When his team removed the covering, they stood in silence for a long moment. The engine was enormous. It had 18 cylinders. These were arranged in 2 rows of 9. This radial setup explained the P-47's bulky shape, but size alone did not stun Schultz. It was the quality, precision, and advanced engineering. Every part was machined to tolerances German factories struggled to maintain. The cylinders were uniform, perfectly balanced. The crankshaft was a masterpiece of metallurgy. Schultz pulled out his notebook and calculated. Based on its design, this engine produced at least 2,000 horsepower. Possibly more with the turbo supercharger system he saw integrated into the fuselage. For comparison, the BMW 8001 radial engine powered the FW190. That engine produced about 1,700 horsepower at maximum output. That pushed German engine technology to its limits. The Americans were mass-producing engines with 20 to 30% more power. They did it with apparent ease, but it got much worse. Schultz examined the engine for shortcuts. German factories often made these. They used lower-grade materials. Manufacturing was simplified. Anything to save resources, he found none. This engine used high-grade aluminum alloys. It had precision bearings. Components showed no material shortages. There were no manufacturing shortcuts. It was built correctly, not expediently. One assistant, a mechanic, pointed to the cylinders. "Sir, look at this. Each cylinder is individually removable. If one is damaged, you replace only that part. You do not disassemble the whole engine." Schultz nodded. It was brilliant. This meant faster repairs, less downtime, more aircraft operation. German engines needed much disassembly for big repairs. This American design assumed frequent, efficient maintenance, but something else caught Schultz's attention. It made his stomach tighten with dread. The P-47's real performance secret was not just the engine. It was the turbo supercharger system. Schultz had read secret reports about this, but seeing it in person was different. A complex network of ducting snaked from the engine. It went down through the fuselage. It led to a turbine in the rear of the aircraft. The system used the engine's exhaust gases. These spun a compressor at over 20,000 rotations per minute. This forced pressurized air back into the engine. The engineering was staggering. The exhaust had to go through ducting. This ducting had to withstand extreme heat. The turbine had to spin at speeds that would tear apart inferior bearings. The entire system had to be precisely calibrated. This avoided damaging the engine. German engineers had tried turbo superchargers, but they had never successfully fielded one. The technical challenges were too great. Materials were too difficult to source. Manufacturing was too complex, but here it was in an American fighter. It was being mass-produced, not a prototype, not an experimental aircraft. A production model, one of hundreds or thousands. Schultz did the calculations. With this turbo-supercharger, the P-47's engine kept full power. This was at heights where German fighters gasped for air. Above 25,000 feet, the FW-190 and Bf-109 lost performance. Their mechanical superchargers struggled in thin air. The P-47 would then be at its best. It would be fast, powerful, and dominant in the high sky. German fighters had to operate there to intercept bombers. His assistant asked, "Can we replicate this system, sir?" Schultz shook his head. "Not with our current manufacturing capacity. This system needs precision machining. It needs high-grade steel alloys. It needs thousands of man-hours of skilled labor. We already struggle to produce basic aircraft. Adding this complexity." He paused. "It is beyond our capabilities." The realization was crushing. Americans built a fighter with industrial skill Germany could not match. After examining the engine, Schultz turned to the airframe. What he found was equally disturbing. The P-47 had taken battle damage. Cannon shells tore through the fuselage. Machine gun fire riddled the wings. Yet the aircraft flew back. It made a controlled landing. Schultz examined the damage patterns. Multiple 20mm cannon hits. These typically shredded German fighters, but the P-47 structure absorbed the hits. Its heavy aluminum skin, robust framing, and redundant control systems meant incredible durability. He pulled out Luftwaffe damage reports. Pilots often reported pumping cannon fire into P-47s. They watched in disbelief as the American fighters kept flying. The reason was clear. The P-47 was built like a tank. German fighters sought weight savings and agility. The P-47 was designed to absorb punishment and keep flying. The cockpit had much armor. Thick steel plates kept the pilot safe from many angles. The front window was armored glass. It was far thicker than anything in German fighters. But most importantly, the R-2800 radial engine acted as a huge shield. German fighters had liquid-cooled engines. These were vulnerable. The radial engine had no such weak cooling system. You could shoot cylinders off it. It would still keep running. Schultz found papers showing P-47s had returned to base. Many cylinders were destroyed. Fuel tanks were pierced. Control surfaces were shot away. German fighters with such damage would have crashed. One engineer remarked, "It's overbuilt. They added weight for strength. This could have been used for speed." Schultz nodded. "Yes, but they can't afford it," he said. "They have powerful engines for the extra weight. We do not. We must make our planes lighter. We lack the engine power to carry more." This was a key design difference. Germany built planes at their technical limit. They squeezed performance from limited resources. America built planes with large safety margins. They used brute force to fix any problems. The American way, sadly, worked better. Schultz next examined the P-47's armament. 8 Browning M250 caliber machine guns, 4 in each wing. His heart sank, calculating the implications. Each gun had about 400 rounds. Total ammunition load was 3,200 rounds. All 8 guns combined fired over 100 rounds per second. The firepower was devastating. A 1-second burst put 100 heavy slugs into a target. A 2-second burst, typical for a firing pass, launched 200 rounds. German fighters typically carried 2 or 4 machine guns. They also had 1 or 2 cannon. Total firepower was less, ammunition more limited. A Bf-109 might have 60 cannon rounds, 500 machine gun rounds. Once expended, the pilot returned to base. The P-47 pilot could fire almost continuously for 30 seconds. This meant multiple long bursts over several engagements. But it was not just quantity. Schultz examined the 50 caliber rounds. They were heavy, high-velocity projectiles. They punched through armor and structural components easily. Pilot reports described P-47 fire as a wall of lead. Now he understood why. 8 guns converging meant anything in that fire cone would be shredded. German aircraft with lightweight construction and limited armor would disintegrate. A P-47 did not need precision. Just get the target generally in front. Then pull the trigger. Schultz made notes. Recommendation: avoid head-on engagements with P-47s. Survival was minimal. As Schultz compiled his technical report, he saw a pattern. It went beyond any single component. Every system on the P-47 showed staggering industrial capacity. The engine needed precision machining and high-grade alloys. The turbo supercharger needed advanced metallurgy and manufacturing. The airframe needed massive aluminum. The armament needed a functioning ammunition industry. Any one of these would strain German industry. The P-47 had all of them integrated into one aircraft. It was also mass-produced. Schultz requested production data. What he learned was soul-crushing. Republic Aviation was building P-47s at an impossible rate. By late 1943, they produced over 500 aircraft per month. Plans called for ramping up to 600, 700, even 800 per month by 1944. German factories struggled to produce 300 to 400 single-engine fighters per month total. German production was constantly disrupted by Allied bombing. But the numbers got worse. The R-2800 engine was not just for the P-47. It powered many American aircraft. Total production would exceed 125,000 units during the war. Over 125,000 of these 2,000 horsepower engines. Germany's entire engine production for all types across the whole war was about 250,000 units. Most were far less powerful. Americans built more of this single advanced engine than Germany produced total engines. The difference was hard to grasp. Schultz sat at his desk, staring at the numbers. He did the math again, thinking he made an error. But the numbers did not change. American aircraft production for 1943 was projected to exceed 85,000 aircraft. German production would be about 25,000, a ratio of more than 3 to 1. But it was worse. American aircraft were, on average, heavier and more complex. One B-17 bomber needed more aluminum and man-hours than 3 Bf-109 fighters. Americans built thousands of B-17s. The material disparity was overwhelming. America fought a global war. They supplied the Soviets with thousands of aircraft and tanks. They equipped British forces. Still, they outproduced Germany in every category. Schultz's final report was due to high command in Berlin. As he compiled his findings, he knew he wrote something dangerous. The report documented the P-47's technical superiority. It acknowledged Germany lacked industrial capacity for equivalent systems. It contained a defeatist conclusion. His summary read, "The P-47 Thunderbolt represents industrial and technological sophistication. This level exceeds Germany's capabilities. Its widespread deployment suggests American production capacity. This far exceeds previous intelligence estimates." Recommendation: tactical adjustments to minimize engagement with P-47 at high altitude. Strategic assessment: continued attrition against numerically and technically superior enemy aircraft will result in unsustainable losses. In other words, we can't beat this, and if we keep fighting the same way, we'll be destroyed. Schultz's commanding officer read the report. He looked at Schultz with respect and concern. "You know this will not be well received in Berlin," he said. "They do not want to hear American aircraft are superior." "Should I alter the findings?" Schultz asked, already knowing the answer. "No, the report is accurate," his officer replied. "But prepare yourself. Leaders don't respond well to uncomfortable truths." The report was forwarded up the chain. Schultz never received an official response, but he heard through informal channels it was dismissed as overly pessimistic. One staff officer reportedly said, "This engineer is demoralized by enemy propaganda. The P-47 is crude American engineering inferior to our designs." Schultz wasn't surprised. He had seen this pattern before. Intelligence contradicting Nazi ideology was rejected regardless of its accuracy. For Schultz personally, the P-47's examination was a revelation, not just about the aircraft, but the war itself. In months after his report, Schultz watched his predictions come true. P-47s appeared in increasing numbers over Europe. German fighter losses mounted. Experienced pilots were shot down, not replaced. His tactical recommendations, avoiding high-altitude engagements and using hit-and-run tactics, were slowly adopted. But then it was too late. Americans achieved air superiority through numbers and technical advantage. Schultz examined other captured American aircraft. Each told the same story: Superior materials, sophisticated systems, evidence of an industrial base unmatched by Germany. He saw a captured C-47 transport plane. It was one of over 10,000 produced. Germany's entire transport fleet was a few hundred aircraft, mostly old designs. He examined a P-51 Mustang. It combined the P-47's range with even better performance. Its engine was a Packard-built Rolls-Royce Merlin produced under license in America, thousands of them. Every aircraft he examined reinforced the same conclusion. Germany was losing an industrial war to an enemy with overwhelming material superiority. What haunted Schultz was that this information was available. Intelligence existed. German agents reported on American production. Captured equipment proved the quality, but leadership refused to accept it. Or more accurately, they accepted it. Yet they believed German will and superior tactics could overcome material disadvantage. Schultz was an engineer. He believed in numbers, mathematics, and physical reality. Physical reality was undeniable. Germany was being buried under an avalanche of American steel. After the war, production figures were declassified. Schultz's estimates proved conservative. He underestimated American capacity. Total American aircraft production from 1940 to 1945, over 300,000 aircraft. German production in the same period, about 94,000. The United States produced over 15,600 P-47 Thunderbolts alone. This was more than Germany produced Bf-109s and Fw-190s combined. The R-2800 engine Schultz examined with awe in 1943. Over 125,000 were built, not just by Pratt & Whitney but by Ford, Chevrolet, and other car companies. Industrial mobilization was unprecedented. American car factories retooled to make aircraft engines. Shipyards building freighters built aircraft carriers. And it wasn't just quantity. Quality remained high. Late-war American aircraft showed no declining standards, no shortcuts, no compromises forced by shortages. German aircraft, by contrast, showed more resource constraints, lower-grade materials, simplified construction, quality control issues. This was as experienced workers were drafted and replaced by forced labor. Schultz survived the war. American technical intelligence officers interrogated him. They were interested in his 1943 report on the P-47. "Did you really conclude from examining one aircraft that Germany would lose the war?" an American officer asked. Schultz paused. "I concluded Germany could not win an industrial war against America. The P-47 showed a production capacity we couldn't match. Every component, every system needed resources and manufacturing capability. It exceeded Germany's total capacity. But you were just one engineer. Surely others reached the same conclusion." "Many did," Schultz replied. "But in the Third Reich, stating inconvenient truths was dangerous. Better to remain silent than be accused of defeatism." The officer nodded. "We found your report. It was marked filed, no action required." "Did that surprise you?" Schultz laughed bitterly. "No, I expected it," he said. "Nazi leadership didn't want intelligence. They wanted validation of what they already believed. When reality contradicted ideology, reality was dismissed." The story of Werner Schultz and the captured P-47 is a microcosm of Germany's strategic failure. A trained engineer examined enemy equipment. He reached an accurate conclusion about Germany's industrial disadvantage, and he was ignored. His experience paralleled Admiral Canaris. Canaris warned about American industrial capacity. Albert Speer knew Germany couldn't win a production war. Adolf Galland recognized the P-47's tactical superiority. Sepp Dietrich knew the Ardennes offensive would fail for lack of fuel. In every case, competent men saw the truth. They were trapped in a system where truth was subordinate to ideology. They provided accurate assessments, but they were dismissed as defeatists or pessimists. The Nazi regime believed German racial and cultural superiority would overcome material disadvantage. That will and determination mattered more than industrial capacity. That ideology could defeat mathematics. They were wrong. Men like Schultz knew they were wrong. They knew this from examining the evidence. But knowing truth and acting on it are different. Schultz's report on the P-47 should have been a wake-up call. This should have caused a major rethinking of Germany's military standing. But it was simply forgotten. The P-47 became one of the most made fighters of the Second World War. Over 15,600 were built. These planes destroyed thousands of German aircraft. They supported the invasion of Europe. They helped achieve air control. This made Germany's defeat certain. It all began when one engineer examined a captured plane. He realized his country had already lost a war. They did not even know they were fighting it. This was not a war of soldiers or tactics. It was a fight of factories and resources. The side with more oil, aluminum, steel, and industrial strength would surely win. America had these things in plenty. Germany had none of them.